Hello, this is Dr. Mears. Today we are going to be learning how to write equations. You have been given a worksheet. This is Novice 1. I'm going to read the situation to you, so please read along on your worksheet as I read with you, and then we're going to proceed to do it together. There are many business situations in which the quantity of items sold depends on the price of the item. Market research has shown that attendance, A, at a small theater depends on the price, P, for charged tickets. To get a better picture of the relationship between attendance and price, take a look at this table. So we have price in dollars, which is our P. These are our X values. Attendance, which is A as a function of P, and those are our Y values. And so we're used to seeing tables. Part A says, use the numbers from the table to show that there is a constant rate of change. Then find the constant rate of change of number of attendees per dollar, which is our slope. And we just took a formative on how to do this. So what you should do is I want you to actually show that you're subtracting that first number minus that second with your arrow and what you get. So it would be 10 minus 0, which is 10. And then 20 minus 10, which is 10. And then 30 minus 20, which is 10. 40 minus 30, which is 10. So on and so forth down the line until we can see here, we get 10. I want you to do the same thing for the y's. Negative 100. 1,000 minus 1100. Negative 100. And here we probably feel comfortable because we are coming out with the same numbers. But remember, if we weren't coming out with the same numbers, we're going to have to put them in our ratios and reduce anyways. So again, if you were getting different numbers every time, keep proceeding because we have to put them in our ratio to find our constant rate of change. Okay, so here are our rate changes of the x, our changes of the y. We now have to put them in the slope, so put them in a ratio. Let me move down. So here we want a ratio. Notice this is the change in y here. This is the change in x. They are all the same, so I don't have to do this over and over to check because it does have a constant rate. So negative 100 over positive 10. I am going to reduce this. Please reduce. So we're going to come out with negative 10 over 1. So that's what it's going to write. You're going to write here the reduced fraction. Negative 10 over 1. So please make sure you reduce. What does this number tell you? I have provided a nice answer for you so that you can start writing these sentences using your communication. You may actually change the sentence into something you like a little bit more by using maybe the word per. But let's start with our sentence. As the attendance decreases by, and you can see the decrease is that minus, so they already gave us that minus. So it's decreasing by 10, and that's what that minus sign means here, that negative sign. People change in y. The price increases, we have a positive, a plus sign here, because this was a positive 1, and this is dollars, so by $1, which is our change in x. So we're going down by 10 people per $1. Now we need to construct a scatter plot. So here's our scatter plot. Notice that the axes are labeled for us, ticket prices. Each box is 10, 10, 20, 30, 40, 50, 60. However, just the 20, 40, 60, 80 are shown, but again, each box is 10. So if you need to fill in each one of these, it may help you see it a little bit better. So please be careful to recognize what each box is worth. Also over here, each box is 100 here, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, 1,100. So again, you may want to put those numbers in. That helps you a little bit more. So we are going to be going back up to this table here, and we're going to be plotting our points. And when we plot our points, we are just going to plot 0, 1,200. 0, this is a point. and this is a point. So 0, 1,200. 0 on the x, 1,200 on the y. Go back down to our graph. 0 on the x, up to 1,200 on the y. The next point is 10 and then 1,100. 10 and then up to 1,100. Then the next one is 21,000. Then 3,900. 4,800. 5,700. And 6,600. Notice it is making a linear trend. That is because we do have a constant rate of change, which is, again, down 10, right 1, or not reduced, it's going to be down 100, right 10. And that's what actually you see here. You see the down 100, right 10, 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 down 100, right 10. Yes, I did the whole thing. So you're going to see we make a line. What's next on our directions? Let's see here. Next it says connect the points with a line. Make sure the line intersects the y-axis and passes through the points. So we're going to have to get a ruler out. I'm going to get my trusty little bookmark here. And we're going to make a line. Make sure we intersect the y-axis, and it goes for all the points. So here we go. So here's where we see it intersects the y-axis right here. And I'm going to put little arrows on it because this point, our line can still go on. Nice line. Here we go. All right, let's flip the paper over. Let's see what we're doing next. Where does your line intersect the y-axis? This is your y-intercept, also known as B. So let's go and find what B equals. So we have to find where the line intersects our y-axis. So let's look. So our line intersects our y-axis. Here's our y-axis, and it intersects at this point right here at 0, 1,200. Notice what I said, 0, 1,200. And if you notice on our chart, 0, 1,200, that's going to be very important for us. So let's write here that where does our line intersect the y-axis? It's going to be 0, 1,200. This is known as your B. So this number right here, this 1,200, that is our B. So our B is 1,200. And this is the point where our line intersects it is 0, 1,200. What does this number tell you? Well, here's our nice communication answer. Again, I wrote it out as a sentence to help you begin using communication. When the ticket price is, that's the X value. So let's look back up here. Remember, I'm sorry, I circled it. Remember, this is the point. So this is our x value. This was our y value, also known as b. So when the x value, let's look at x, the value is 0. There are blank people. We have to look for our y value. Our y value was 1,200 attending the theater. So let's read this again. When the ticket price is $0, there are 1,200 people attending the theater. So that's what it means. It means when we have 0 as an x value, that's what our y value is going to be. So let's write an equation, which is next. Substitute m and b into y equals mx plus b to create a linear equation. So this is the whole concept that we're getting to. We have to keep the y, keep the x, keep the equal sign. These are all important. You need a y, you need an x, you need an equal sign right now for our equations. We're going to see that we do come up with different equations. Maybe that might not have an x or might not have a y. They do all have equal signs. But for now, for our beginning writing equations, we are going to be needing a y, an equal sign, and an x. So let's see what we have here. Our equation, it says substitute our m in. So our m was our slope. So looking back at our paper, our m, we're going to go to our reduced slope, negative 10 over 1. And that's what we're going to put in. You could reduce that to negative 10. Negative 10 over 1. You could also write that as negative 10. I'm not going to write that for you in 1 second. X plus our b. Let's look for our b. Our b was 1,200, 1,200. So writing an equation this way where our slope is a fraction, that's okay. But we can simplify this because negative 10 divided by 1 gives us negative 10. So our better simplified version would be y equals negative 10x plus 1,200. So this is our simplified version. Sometimes, though, our slope will not be able to be reduced down to an integer like this. Sometimes we might have 2/3 or 4/5, so we can't reduce it. So having a fraction as our slope in our equation is absolutely fine. But if you can make it, look, y equals negative 10x plus 1,200, that's nice. Next, use your equation from part E to predict how many people would attend if the ticket price was $120. Extend your graph and plot this point. What is the significance? So this is what it wants us to do. It wants us to write down our equation, y equals negative 10x plus 1,200. And it's asking ticket price was $120. Remember, ticket price is the x value. So we have to use some substitution here. So in place of the x, we're going to input 1,200. And I did say that as input because this is our input. We're actually going back to looking at functions again because we're looking at linear functions, which is our unit. So y equals negative 10. Where the x is, we're going to input the 120 plus 1,200. And we're going to see what we get as an output, which is our y, and our y is our output value. So let's do that. Y equals, let's do our multiplication, negative 1,200 plus 1,200. And when we do negative 1,200 plus 1,200, we are going to come out with 0. And that's pretty interesting because our y equals 0. Let's go back. It says extend our graph and plot this point. So our point is xy, remember. X is first, which is 120. That's what they gave us, our input. Our output was 0. So the point that we're going to have to plot is 120, 0. So let's go back over here and actually plot that point. 120 on the x. Here's our x-axis. Here's 120. There's the bell. Love when that happens. And then let's extend our graph. Almost finished here. Here's 120. Let's go back and look at our communication sentence. I almost made it before the bell. When ticket price is 120, there will be, let's see, our output, 0 people, which is our y value, attending the theater. This is also called the x-intercept. So we touched upon a lot. We touched upon slope, y-intercept, writing a nice equation, and also x-intercept. I hope this helped. You have a couple examples that you can do with different worksheets. Please, please, please review, rewind, redo. Again, this is Dr. Mears, and we're writing equations.